Stop debugging connection drops. If your AI agent crashes when the network hiccup occurs, you're not building software, you're building a high-stakes guessing game. For most developers, the AI agent prototype is a sandbox toy. It works until it hits the real world, latency spikes, service timeouts, and network partitions. The transition from MVP to production requires a fundamental architectural shift. You need reliability baked into the DNA of the agent, not bolted on as an afterthought. The solution isn't more code, it's a pattern. We use durable streams to treat the agent's execution not as a single run, but as a series of recoverable checkpoints. Think of durable streams as the agent's persistent memory. It records its state after each successful step, allowing it to rewind and resume exactly where it left off. This persistence is the key to achieving true fault tolerance. If the compute instance dies, the stream holds the truth of what was accomplished. But memory isn't enough. We need to map the volatile runtime state, the context variables, in-memory caches, and current task queues to that persistent stream. This is where checkpointing comes in. Before the agent executes a step, it serializes its entire working memory into a defined schema, packaging it for the stream. Let's look at the code. When we reach a critical decision point, our agent must commit its current state before proceeding. Here, we define the serialization method. We dump all transient variables into a structured payload ready for persistence. The stream receives this payload. It marks the current execution path as complete and waits for the next command, effectively achieving a safe commit. Now, consider failure. If the service crashes during execution, say, before that commit completes, the stream simply holds the last known good state. When the service restarts or a new worker picks up the task, it doesn't start from scratch. It reads the final committed checkpoint. Deserialization reconstructs the exact memory picture, variables are restored, pointers match, and the execution context is perfectly preserved. This is the recovery mechanism. The agent bypasses all infancy and goes straight into high-velocity execution from the point of failure. But survivability isn't just about recovery, it's about knowing when to try again and when to admit defeat. This leads us to intelligent retry logic. We must differentiate between transient failures, network blips, temporary API rate limits, and fatal errors like invalid input or business logic flaws. Transient failures trigger the retry loop. The agent doesn't crash, it rolls back to the last checkpoint and tries the step again, safely. The retry count must be managed. Indiscriminate retries just create noise and potentially infinite loops. Once the threshold is breached, or if the error is fatal, the agent must gracefully fail and hand off to a human operator or an alerting pipeline. This graceful degradation is the difference between a production-grade service and an expensive hobby project. Implementing this robust pipeline means your agent scales not just in throughput, but in resilience. It is now a reliable asset. If you are deploying agents that interact with external services or handle critical business logic, this pattern is non-negotiable. The durable stream doesn't just record state, it provides the transaction log necessary to maintain ACID properties across distributed execution. It turns a sequence of ephemeral compute steps into one monolithic, dependable transaction. So, the next time you build an agent, don't just focus on its intelligence. Focus on its infrastructure. Build it to survive. Build it with durable streams.